Hello guys, welcome you all for this end-to-end session on AIML where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying. We are enjoying and we are learning a lot. Hope you guys are doing the same. So yeah, today we're gonna see one more algorithm. It is a gradient boosting algorithm. So it's like I will say it's an advanced algorithm we are having in machine learning. So that is what we're gonna see. So before coming to the session, please make sure guys, as always, make sure like you guys have watched all our previous session videos and then just come to this session so that you can have a better understanding of what we are telling. Okay, so yeah guys, that's the thing. And one more thing, like if you guys face any difficulties, anything related to data science field, anything that we have covered or anything that we need to improve, just ping us in the comment section. We will take up and we will try to improve or try to solve your doubts, anything it's related to it. Okay, so yeah guys, one thing, we are here to help you the journey of data science, anything it can be. Okay, so yeah, we are here only to help you. Okay, help you and guide you. We will be like a mentor for you. Okay, so yeah guys, without wasting any time, today we will be moving on to the session which is on gradient boosting. So it is going to be a theory session. Okay, let's understand the black box behind this gradient boosting algorithm. Okay, so gradient boosting, a powerful tool in data science. Yeah, I'm also like agreeing. I hope like sir will also agree, because like till now we have seen different algorithms, right? uh, so all the algorithms will be learning based on data. Okay, but here it will learn based on models also. Okay, let's see how it is working. Okay, so yeah, so gradient boosting, a powerful tool in data science. So gradient boosting is a machine learning technique widely used in data science. It's a powerful and versatile method for building accurate predictive models, making it a valuable tool for various tasks. Okay, as I'm mentioning, like this is going to be something different when compared to all other models, where each models which we have seen will learn from the data, whereas this model, gradient boosting model, will learn from the weak learners, that is weak models, and you create the strong models out of it. So it is somewhat powerful. I will say somewhat no. It's powerful than all other algorithm. Okay. So yeah, that is what the introduction about this gradient boosting. Yes, sir. Over to you.
Yeah, so guys, first of all, do reinforce learning. Watch all the previous session 5 to 10 times, absorb the information, digest the information, and apply. So, build a long-term vision for learning, okay, and keep continuously learning with patience, persistency, consistency, and perseverance. So, when you continuously learn, you acquire knowledge. Knowledge is not, guys, what is written in books and what is visible to your eyes and what people are talking. If you really want to build knowledge body, you have to go 100 layer deep into that concept. You need to know the limitations of the knowledge representation. Ontological study you have to do. So ontology is knowledge of knowledges, right? So you can see, I'll give example. So like you see bird flying, you call it, oh, bird is flying, but that is just an if you see in knowledge body, that is just one aspect in thousand aspects, because there are so many mechanics in when bird is flying. Okay, if I ask you, okay, you build a robot who will fly, then it will be a real test of your knowledge, that how many knowledges you have to learn: mechanics, coding, biology, lot of aspects you have to learn that. So programming, lot of things you have to learn: aerodynamics, then it should fly, then it should take off, lot of things. So we are just saying, we say bird is flying, okay, it's just a sentence, but there is a ontological deep understanding, knowledge of knowledge, knowledge of knowledge, knowledge of knowledge, knowledge of knowledge, and then it goes to quantum levels, okay, where everything is generated and everything goes back. So you need to build that kind of knowledge body. Okay, right now we are just scratching the surface with this program, guys. Okay, so build that deep persistence, and which Elon Musk had. Okay, so a lot of students, lot of people will bully him, but he built a deep persistence, and he's going to be a $1 trillion first trillionaire, guys, in the world because of knowledge body, because he understands concept like nobody else does, and he started from scratch. In his lifetime he is going to be a trillionaire. That is the magic and that is the power of a knowledge, guys. But what knowledge body, very deep and persistent, consistent, perseverance kind of knowledge body, which is like meta level, deep meta level, ontology, knowledge of knowledge, knowledge of knowledge, knowledge of knowledge. When you reach that level, you will have one simplicity, you will have stillness, and you will build that that kind of magnetism in you, guys. And then whatever you touch, it becomes gold. So pursue excellence to that level. And so let's now go to this. The concept is gradient descent, okay? So you know, guys, what is ascent? Ascent means going up. Descent means going down. So gradient descent boosting, a powerful tool in data science. Okay, so gradient descent boosting is a machine learning technique widely used in data science. It's a powerful and versatile method for building accurate predictive models, okay, and making it valuable tool for variety of tasks. So with simplicity, right now, just understand it's a very powerful tool which gradient boosting, okay. Sorry, I said gradient descent. That's gradient boosting is the concept. So we have, you will learn about gradient descent and all. So here gradient boosting is just, it's a powerful machine learning tool um, which helps us. It's a versatile method building accurate predictive models. Mainly is predictive models. So if you see predictive word, so it again comes from stat. So we want to predict, forecast. Okay. So predictive model, it builds that, and then it makes it making a valuable tool for variety of tasks. So that is gradient boosting. Okay. So yeah, let's move to the other section. We'll go a little deeper and understand this particular algorithm, and then we'll go for application in future sessions. Thanks.
Yeah, sir. So moving on, let's see what we are having next. Okay. Let us see what is ensemble learning technique. Guys, if I mention this, you guys already know what is ensemble technique. We have seen one ensemble method. What it is. Guys, if you remember that mentioned in the comments, what is the algorithm name which is called, which uses ensemble learning? I hope like most of them will be able to answer this, because like I think last before session we have completed it. Okay. So guys, please ping in the comments that what is the ensemble technique that we have seen. Okay. Yeah, the answer is random forest, guys. So multiple models combine together to create a model, then it is called as the ensemble learning technique. So whereas the random forest is built up of multiple decision trees, right? So it is one of the ensemble learning technique. Random forest is one of the ensemble learning technique. Let's see what is the ensemble learning technique. Ensemble method. Ensemble learning combines multiple machine learning models to improve the predictive performance. Yeah, we have discussed it. Okay, related to like decision tree, we have multiple decision tree based on the majority voting or average score. We will be going for either classification or regression. So multiple machine learning models which we have done to improve the predictive performance. Okay, next it's diversity. Combining diverse models can reduce overfitting and improve generalization. Okay, so when we are stick to only one model, then the depth or height or the way that it is communicating or the way the equation is used for the model will lead to overfitting. But if we combine multiple machine learning models, it will become, the model becomes generalized. So that's the reason, that is one of the reason of diversity what this ensemble learning techniques do. Next is bagging. Bagging involves creating multiple models from random subset of data. Okay, in this ensemble learning technique, we will not feed entire data to all the model. We will split the data and we will be given to multiple models, and based on that we will be getting the result. So that is what bagging. Okay. Next we are having boosting case. Boosting sequentially build models focusing on correcting the error made by the previous models. Guys, now you guys need to understand. This is boosting. We are talking about gradient boosting. So what is meant by boosting? We have the data, we give the data to the model predicts, and that is considered like there is 50% error. The next model takes this 50% error together with the training data, and now it will train means it gonna get something greater than 50, like consider it as a accuracy of 70%. Now, and there is an error, right? So previously the error is 50%, now the error is 30%. Now it uses the next model, it will go for the next model, it will take the error of the previous model plus whatever it can do. Okay, so like that, if you move on, then the accuracy, like the error further reduce to 20%, 10%, like that. So sequential models will reduce the error of the previous model such that we obtain a model which has the greater accuracy. Okay, that is what boosting. Bagging, we split the data, give to multiple models, then we go for average voting or like averaging or voting method, and we will find the answer. Whereas boosting, first model, input data, it train and gives the accuracy, and in order to reduce it, we go for the next model and we will provide the data and another accuracy. In order to increase the accuracy or reduce the error, we will go for next model, like sequential approach. Whereas bagging is a parallel approach. Hope you guys can understand, guys. You need to just exactly understand this, guys, because like I will say all the interview session they're gonna ask what is bagging and boosting. Bagging is the parallel approach, whereas boosting is the sequential approach. Okay, that is what the baseline you need to understand, guys. Okay, make sure you guys have understand. If you guys doesn't understand, just ping in the comment. We are here to help you. Yes, sir. Over to you.
Yeah, guys. So ensemble learning technique is we combine different models, different techniques, okay, machine learning models to improve the predictive performance. That is the main objective when you hear or when you use. So this is the main objective, okay? Then diversity combines diverse models can reduce overfitting and improve generalization. That is what you have to build a optimal model, right? That is very simple, huh? Bagging. Bagging is it involves creating multiple models for random subsets of the data. That's what bagging means. Boosting. Boosting means it's sequential builds boosting sequentially builds models focusing on connecting errors made by previous model. So it see boost, like if you see the word, it's like it boosts your like kind of energy. In human beings, we also drink different energy drinks, right? That boosts our energy. Similarly, this model, this boosting also boosts, okay, focusing on correcting the errors which have made previously in the model. So it boosts that so that it can not do that, so that the performance again is good for the model. That's it. This is very simple. So yeah, let's move to the other section.
Yeah, sure, sir. We can move on. So, guys, yeah, that's the thing. So, you guys need to understand what is boosting. So, then only you can able to understand the gradient boosting. Okay. Hope you guys have understand. Okay. Let's move on to the next slide. Okay. Yeah. So, boosting algorithm, guys, we are having multiple boosting algorithms. Okay. First is ADA boost. ADA boost means adaptive boosting. So, which assigns the higher weights to the misclassified instances such that the next model, the sequential model, will have the will reduce it. That's the thing. Okay, that is what the ADA boosting. It is one of the boosting method. Okay, next let's see gradient boosting. Gradient boosting is used to minimize a loss function by sequentially adding the weak learners. Okay, what this gradient boosting will do means it will sequentially order different models and tries to minimize the loss in each and every model. That is what gradient boosting. Then we are having XG boosting. XG boost, extreme gradient boosting, is an optimized and scaled version of this gradient boosting. Light GBM. that is light gradient boosting machine. Is a effective, highly effective and fast gradient boosting algorithm. Okay, guys. Except ADA boosting, gradient boosting, XG boosting, light G, light GBM, everything belongs to gradient boosting. So you need to understand two things. ADA boosting means it is gonna give high weightage to the classified instance so that the next time it will work better. Whereas for gradient boosting, it is used to minimize the loss function for in this sequence of models. This XG boosting and then the light GBM are derived from this gradient boosting. Okay, hope you guys can understand. Okay, very simple explanation, guys. So these are the boosting algorithm that we are having. Major thing, base thing, and the scarce thing is gradient boosting. Okay, where we will be reducing the sequential models. That's it. Okay, we are gonna remove the errors each and every stage. Finally, we get the stage where we will be having very less error or no error. Okay, hope you guys can understand. Yes, sir. Over to you.
Yes, so boosting algorithm. So we have add boost, which is adaptive boosting. So it assigns higher weights to misclassified instances. So it will assign higher weights. Okay. So you guys know what is weights. So can you just write in the chat, uh, in the comment section, what are weights? Because that you will hear a lot when you go for AI, ML, or data science. So you will hear these words a lot. What is weights? Okay, so that I'll keep that loop open. So gradient boosting. Then we have second part, which is gradient boosting is minimizing a loss function by sequentially adding weak learners. Okay, so the main objective of gradient boosting is minimizing the loss function. Loss function is like you, if there is a problem in the data, so you are not capturing the right essence, okay, that it is going to minimize. So if you're losing some kind of information, or the model is not learning properly, so your gradient boosting is going to actually maximize the loss function by sequentially adding weak learners. So gradient boosting is going to minimize, okay, the loss function. That is the main concept in gradient boosting. Okay, then we have X uh, boosting, which is extreme gradient boosting, an optimized and scaled gradient boosting algorithm. It is extreme is better than the gradient boosting, guys, because it is extreme, like it optimizes and scales the gradient boosting algorithm. So the normal gradient boosting, it optimizes it. Okay, so that is why it is called extreme gradient boosting. Okay, then we have light GBM. Okay, then that is again gradient boosting, light gradient boosting machine, which is like it is highly efficient and fast gradient boosting algorithm. It is like, that's why the name is light. It's because when you're light, you're fast. If you see physics concept, so whatever thing is light, it will move fast because, right? If it is heavy, it will not be able to fly. So it will not be efficient, right? So even people who are very heavy, they can't run fast. People who are lean, athletic, they run fast, right? Similarly, light gradient boosting machine, you can remember with these analogies so that it is highly efficient, fast, okay? Lighter are fast, efficient. So this algorithm helps, like it gives you fast results, it works fast, it is efficient, and these are four gradient boosting algorithms which help us to ultimately optimize. Because see, overall objective function of AI ML data science is, guys, what? To optimize the objective function, the optimize the models so that we are better at performing the task, resource, and time. That is the Resource and time are two factors. Like our models should be very, very efficient. Otherwise, we human beings will do that work. Now, why we need models and machine learning? So we need optimized models, and so that our objective function is achieved with efficiency and performance. These are two very critical aspects for entire end-to-end AI, ML, and data science. So you need to understand that is why these models are built. So ultimately, if you see any model, the work is to optimize. The work is to optimize. That's it. To get the better performance from the model. That is the basic logic for all the models, guys. But according to the objective function and characteristics of the data. Okay, let's move to the other side.
Yeah, sure, sir. So, guys, this is all about the boosting algorithms that we are having. Let's move on to the next slide. Okay, gradient boosting fundamentals, guys. I hope like now you guys need to be very clear. This is what the black box began the gradient boosting. Let's see. Weak learners, gradient boosting builds models sequentially, starting with the weak learners. What is meant by weak learners? We have an entire data set we are putting to some model. Model will start learn slowly, and there will be poor result at the first. They are called as weak learners. Then what is my loss function? Loss function measures the error of the model's prediction. Okay, so how much it differs from the actual value, that is what loss function. Gradient descent, the model's parameters are adjusted to minimize this loss function. That's it. Okay, to minimize the loss function. So this is what the major thing that you guys need to understand when it belongs to fundamentals of gradient boosting. Weak learners, this gradient boosting builds the weak learners step by step. Finally, all the weak learners errors are solved and it becomes a strong learner in each and every step. Loss function, it measures the how much accurate or how much error your model perform models with that you have built as. Then the gradient boosting is used to adjust the parameters of model to minimize this loss function. Okay. Hope these are simple, guys. I don't know, like it gonna be like anything like very difficult to understand. No, nothing. Okay. So this is what all about this gradient boosting fundamentals. Weak learners, then we are having loss function and gradient descent. Okay. Hope you guys can and are able to understand. Yes, sir. Over to you.
Yeah, so gradient boosting fundamentals. So weak learners, so gradient boosting builds models sequentially starting with the weak learner. So it will try to improve, right? You have seen different algorithms. You've seen extreme, you have seen light, you have seen different. So it starts with weak learners, okay? So then we have loss function, which is the loss function is measures the error of the model's prediction. So this measures the error of the model's prediction. Okay. Loss, if you see, loss will be the errors, the anomalies, right, in the model. It is going to measure that in the model's prediction. Okay, that's what it is going to do. So how much is the loss? How much is the error? What are the anomalies and stuff? It is going to help. Okay, once you measure, then you can boost it. That's what the idea is. Because you need to, okay, suppose I go to doctor. If I knew myself what is the medicine required, what actually problem is, I will not go to doctor. Nobody will go to doctor, right? We go to doctor to know exactly what is the problem. So this is how with loss function we measure the error of the model's prediction. So once that is discovered, then we can have solution for that, and then we have gradient descent, which is models, which I earlier spoke. It's a model's parameter. These model's parameter are adjusted, minimizing the loss function. So that's what loss function is, like the errors. Okay, because see, if you have to understand this terminology, loss function, it means that whatever is not helping in your model to perform better. Okay, so it is going to minimize that. Okay, so it will go up, it will go down, it will go up, it will go down, and then it will try to minimize, adjust the loss function. That is the main purpose of a gradient descent, guys. Okay. So if you have seen mountains, so there is a algorithm called hill climbing algorithm, different. So gradient descent is like that. When you have seen peaks and valleys kind of thing, it will try to behave like that. Okay. So it will try to adjust, because when we go to if you have climbed mountain, you go up and down, you always try to adjust. Whether you're going up, you have to adjust, you're going down, you have to adjust. So that's what gradient descent will do. Okay. So I'm just giving analogy so that you will remember the actual essence and concept of it. Okay. Because when we relate with real life, so we understand things in a different manner. But we also need to understand what is happening in the black box as per the equation, as per the algorithm and function, mathematical function. That's also very important. Okay. So let's move to the other section.
Yeah, sure, sir. So, guys, I think we can pass here. So, we have started with the introduction about this gradient boosting. We have started what is ensemble learning. Then we have gone through the different algorithms that are present in this gradient boosting, and finally, we have seen the fundamentals of gradient boosting. Hope you guys have enjoyed this session. This is like completely introduction about gradient boosting. Next session, we will continue the theory of this gradient boosting, and then we will end up with the like next session. We will end up with the code for this gradient boosting. Okay. So yeah, guys, that's all about this session. And one more, guys, one more thing. If you guys are still watching till this day, you guys are very, I say you are just amazing, guys. Okay, because like it's a everyday's challenge. We will say it is a challenge to like 365 days challenge, a year challenge. So if you guys are to this point every day, then it's great. I'm just appreciating each one of you. So yeah, that's the thing. If you guys are anyone who is watching, uh, that doesn't subscribe to our channel, please subscribe to our channel, because like it's gonna be a year-long program. You're gonna get everything that you need, like theory part of data science, coding part of the data science, and then black box of data science, and then like everything. Okay, what are the industrial applications we are having related to data science? Everything you're gonna have for this 1 year. Okay, hope you guys have enjoyed. If you guys have any doubt, just ping in the comment. We will take up and we will solve the doubts. And if you guys have like anything else related to this data science field, any doubts related to data science field, just ping in the comment. We will take up and we will solve your doubts. Yeah. So that's all from my end, guys. So if you guys have like feel any difficulties in anything, like again mentioning, like please make sure that you are put in the comment and we will take up and we will solve it. Okay. So yeah, guys. Until next time, until next session. Bye, guys. Take care. We will all meet in the next session, guys. Bye, guys.
Yes, guys, keep learning deeply with patience, persistency, consistency, and perseverance, and build a long-term vision. And subscribe to our channels also. Press bell icon so that you will get notification. Stay connected and build deepest level of knowledge body, guys, in your career function, in your like in long-term career. Okay, if you want to build in AI ML data science, or you want to become a AI scientist or data scientist or AI ML engineer or AI researcher, build that. And here, guys, we are here to help you out continuously to build that kind of, so it's deepest level of knowledge body which nobody can touch, even not an AI bot or AI super AI should touch that, because we have to become that kind of human beings now. If we want to surpass AI and super AI or general AI, we need to have deepest levels of knowledge body with us, and that kind of skills we need to have. So with that, see you in the other section. Thanks.